Hello guys and welcome back to my channel Interview with Bunny, and today we are back with another video on system designing playlist, and the topic or the application that we will be designing today is food delivery application such as Zomato, Swiggy or Uber Eats. So the main motive or the main core functionality of this application is user should be able to order food online from any restaurant he wants. So since you guys are familiar with how the food delivery application actually works, so let's start with the first step of our system designing, and that is the gathering of the functional requirement. So as I always tell you in my video that a system designing interview is an open-ended interview where the interviewer will give you a very vague question like design a food delivery application, and it is your responsibility to gather all the functional and non-functional requirement from your interviewer. So without wasting much time, let's get started and let's see what can be the functional requirement of this system. So the functional requirement of this system will be pretty straightforward. That is, once the user opens up our application, the user should be given the provision for sign up and login. Number 2, once the user successfully logs in or registers in our application, we have to show the user all the nearby restaurants that are available and open from where he can order food. Number 3, user should be also given the provision to search for a particular menu or a restaurant from our search bar. Number 4, once the user opens up a restaurant, we have to show what are the list of menus that are available in our restaurant. Number 5, user should be given the provision to select more than one items and add to the cart and place the order by making a successful payment. Now once the order has been placed successfully, our fifth requirement comes, that is, the restaurant have to accept the order and start making the food. And as soon as the restaurant accepts the order, a delivery partner should get allocated for that order so that once the food has been prepared, it can be delivered successfully to the user. So these are the 6 or 7 core requirements of this system. So if you understand the problem statement correctly, there are 3 major actors that are involved in this system. Number 1 is the user who is actually placing the order. Number 2 is the restaurant who are accepting the order and preparing the food, and number 3 is the delivery agent who is getting allocated once the order has been placed, and his responsibility is to successfully deliver the food from the restaurant to the user. So these are the 3 core actors for this application. But remember, during your system designing interview, since exploring all these 3 aspects will take a lot of time, so you have to discuss with your interviewer that which part of our application you should design. So here what we will do, we will try to cover each and every concept in detail, means starting from the user aspect, then we'll come to the restaurant. After that, we will come to the delivery partner, that how the delivery partner will get allocated based on the location. So we will try to cover all those 3 aspects in detail, and we will try to explore all the functional requirements that are possible for this system designing question. So without wasting much time, let's list down all the functional requirements that we are trying to solve in this problem. So here you can see I have listed down all the functional requirements that we have to discuss. So here if you look carefully, there are a lot of things we will be discussing in this video. So this video will be a bit longer than the usual because here we have to discuss in detail that how the order will be placed to the nearby restaurant, how we should assign a nearby delivery partner, also how we will give real-time location update to the user. So these are some of the main important things that we have to design for our food delivery applications. So I hope we are clear with the functional requirement. Now let's see what will be the non-functional requirement for this system. So whenever we talk about the non-functional requirement, it means the characteristics of the system, means how big our system is, how our system should perform. All these characteristics should be discussed within our non-functional requirement. And the first non-functional requirement that we have to discuss over here is the scale of the system, means we have to get an estimation from our interviewer that for how many users we are building this application, because based on that number, there are a lot of critical decisions that we have to take while we will be designing our system. So here once we discuss about the scale of the system with our interviewer will tell us we are targeting about the 50 million users, means our application is used by total 50 million users across the globe, and the total number of restaurants that are listed in our application is around 1 million. So that is a huge amount of scale that we are talking about. So the scale of the system system will be something like this. Now the next thing that we have to consider, that is the cap theorem. And as you know, cap theorem tells that whenever you are designing a distributed system or a microservice application, you have to either compromise between the consistency of the system or the availability of the system. You cannot achieve both the availability as well as the consistency on a single module of our application. So here, if you understand the application that we are designing, here this will be a microservice application, because here we are discussing about the 50 million user, so you can easily identify the amount of traffic that we will be getting in our application. So obviously we have to go with the microservice architecture or with the distributed architecture. And whenever we are discussing about the distributed architecture, we have to discuss the cap theorem. And here if you see, our application should be highly available based on the searching and browsing. Means once the user lands to our application, obviously all the time we have to show all the list of restaurants that are available nearby. So the homepage of our application or the search result should be highly available. And with respect to the payment and placing the order by the user, our application should be highly consistent. So here the next non-functional requirement should be that the application should be highly available based on searching, and our application should be highly consistent based on the payment and ordering of the food from the restaurant. So these are pretty much all the functional and the non-functional requirement for our food delivery application. But here if you look carefully, there are pretty much lots of concepts that we have to discuss in this video. So without wasting much time, if you have got the idea that what will be the functional and the non-functional requirement for our system, let's now go to the next step of our system designing, and that is identification of the core entity. So here if you read the functional requirement clearly, you can easily find out what will be the core entity for this application. So the number 1 will be the user, number 2 will be the restaurant, number 3 will be the food menu or the food item which the user will be looking for, number 4 the delivery agent or the delivery partner who will get assigned once the order has been confirmed, and the last but not the least is the payment module. So these are primarily the core entities that we can figure it out as of now from this requirement. Now let's move to the next step of our functional requirement, and that is the API designing. So if you just look carefully, I am hurrying up a bit to explain all the functional, non-functional and all this aspect. And the reason behind it, we have a lot of things to discuss while we will be discussing the high level and the low level designing of this application. And since these things are quite easy to understand, and since this is quite related to us, so I hope it is quite easy for you to understand that what can be the functional and the non-functional requirement that we have to discuss over here. And believe me, since we have only a 45 minutes to 50 minutes during our technical interview, so here if we are wasting our time too much discussing only the requirement part of our designing, we will not get enough time to implement all this requirement. So that is why I am just hurrying up a bit to gather all the functional and the non-functional requirement till now. But from the third step, that is from the API designing, we will try to go in detail and we will see that what will be the REST endpoint that we need to complete the entire flow of the application or complete the entire requirement that we have gathered. So without wasting much time, let's go to the third step of our system designing, and that is the API designing. So as I tell in all my system designing interview question, that designing the API is quite simple if you have done until this point. Means if you have gathered all the functional requirement properly, designing the API endpoint will be damn easy, because in most of the case API endpoint will have a one-to-one mapping with the functional requirement that we have gathered. So let's see what will be the API designing or what will be the public REST endpoint that we have to expose in this system to fulfill all the functional requirement. So the first functional requirement means we have to give a provision to the user, or we have to open up a API endpoint for the user by which user will be able to sign up in our application. And as you know, once the user is trying to do a sign up, means he is submitting a data into our application, and thus it will be a post endpoint. So let's see how the API endpoint will look like for doing a sign up operation. So this is how our register URL will look like. So this will be a post request, and this is the signature of our endpoint. And here if you see, since this is a post request, obviously we will need a post body. And in the post body, what we will be sending? We will be sending the user metadata, means the name, email ID, password, address, all those user metadata that we need to persist in our database. And along with this registered URL, we also have to give the provision for login, logout, and update. So here you can see I've just mentioned it in the bracket that we will be giving some other endpoints, that is for login, logout, and update. So since this is some of the basic CRUD endpoint that we have to give for a particular user, we do not have to mention the signature of all the endpoints over here because that will be a waste of time. So here you just need to notify your interviewer that here along with the sign up URL, you are also planning to give a get URL for login, logout, and a put URL for the update. So these are more or less all the endpoints that you need to manage or register a user into our application. Now let's go to the second endpoint to fulfill the second requirement of our application. And that is, once the user logs into our application, we have to list down by default that what are the list of all the nearby restaurants that are available. So for example, once we open up the Zomato application, we can easily see what are the restaurants that are available within a radius of 5 to 10 kilometers. So here also we have to create our endpoint something like that. So let's see how the signature of the URL will look like. So this is how our second endpoint will look like. So obviously, since here we are getting the information from our database or from our backend, so this will be a get endpoint. And here if you look carefully, in this URL, we are sending the latitude, longitude, and the radius in the form of the parameter. Means once the user logs into our application, we have to first get what is the latitude or the longitude, means what is the current position of the user where he is opening the application. And based on that coordinates, we have to query this URL to search all the list of restaurants that are available. So for example, I'm trying to log in from a particular location of the Bangalore. So my current latitude and the longitude will go as a parameter over here. And here we will be sending a customized radius, means we have to search all the restaurants on the 5-kilometer radius, or it can be a 10-kilometer radius. So based on that, we have to create our endpoint so that we can get all the list of open restaurants who can provide us the facility of ordering the food. So this is how our API endpoint will look like. I hope this is clear. And here you can see in the return type of this URL, we are listing all the list of restaurant ID over here. And this will be a partial data, means we are not only sending the restaurant ID, rather we will be sending the thumbnail, the name of the restaurant, all those partial data to our front end. And since there can be more than hundreds of restaurants that will be available in your nearby location, so obviously we have to show it in the form of the pagination. Otherwise, it will be overwhelming for your front end to list down all those restaurants in your screen and our system will get hanged. That will be a very bad experience for the user. So this is how our endpoint will look like, which will retrieve all the open restaurant from our nearby location. Now let's go to the third requirement of our system, and that is user should be able to search restaurant based on the title and the menu. So let's see how it will look like. So here if you see, both of the two signature looks more or less the same, but the behavior or the core functionality are pretty different. So here the first one deals with searching all the locations that are nearby to us. And the second endpoint try to search all the restaurant that meets these two criteria. That is, it should match with the title and the food item that the user is searching for. So I hope this is clear. And this endpoint also returns the list of restaurant ID, and it will be also in the form of the pagination. So we are done with the two major functionality, and that is listing all the nearby restaurant based on our geographical location, and number two, searching the list of restaurant based on the title of the restaurant and based on the food menu the user is searching. So once these two major functionality is done, the next functionality that we have to fulfill, that we have to show all the list of the menu that are available in a particular restaurant. So obviously once the list of all the restaurant comes on the front end of the user will definitely click on a restaurant to see all the details on the metadata of the restaurant. And to retrieve those information, we need our next endpoint, and that will be obviously a get endpoint. And let's see how the signature of that endpoint will look like. So this is how our restaurant endpoint will look like. So here if you look carefully, I have created two endpoints to fulfill this particular requirement. So the first endpoint is to retrieve all the metadata of the restaurant. So here in the URL, we are passing the restaurant ID, and the next URL will be the menu, where based on the restaurant ID, it will show to the front end what are the food items that are currently available on the restaurant. So these are the two endpoints that we need to fulfill a single functional requirement, that is show all the metadata or display all the menu of the restaurant to the user. I hope this is pretty straightforward and clear. Now let's go to the next one, and that is user should be able to select various items in the cart and make the payment to confirm the booking. So this is actually a 2 or 3 step process. So here the first step is user have to select an item and add it to the cart. So that will be the first step. Number 2, user have to make the payment to confirm the booking. And as you know, this will be a 2-step process. Means once the order is placed, then another request will go to our payment gateway to get all the payment related information and confirm the booking. So actually, this functional requirement can be fulfilled by 3 API endpoints that we need over here. So let's see what will be the 3 endpoints that we need to serve this functional requirement. So this is how this 3 endpoint is needed to fulfill our 5th requirement, that is placing an order into a restaurant. So let's see one by one that what are the endpoints that we need. So here the first requirement is user should be able to add item into the cart. As since obviously we are adding data into the cart, so this will be a post endpoint, and this is how the signature will look like. So here we are adding the item into the cart, and here in the post body we are sending the item ID. Here the item ID means food ID, means the food that we want to order. And here we have to also specify the number of plates that we want to place an order. Means for example, we need a chicken biryani of 3 plates. So obviously the quantity will be 3 and the item ID will be something for the chicken biryani. So this is the combination that we have to send in the request to add the item in the cart, and here the return type will be the cart ID. And along with that, keep in mind, while we are sending the item ID and the quantity in our post body, we also have to send 2 things. Number 1 is the user ID, means who is actually placing the order, and number 2, the restaurant ID from where we want to place the order. But for the security reason, what we will do, we will not send the user ID in the post body. What we will do, we will send the user ID in the header of the request. So we will omit this from here. But apart from the food item and the quantity, we also have to send the restaurant ID over here. So this will be the 3 major parameters that we need to send in the post request of this cart URL. And along with that, we also have to make 2 other endpoints, that is the update and the delete of the cart. So this is pretty straightforward. And once the item has been added to the cart and we get the cart ID, the next thing is like we have to place the order. And for that we have the next API endpoint, that is the order endpoint. And here in the metadata we are sending the order ID, which have all the list of information about the item, quantity and the restaurant ID. And this order is getting submitted in our backend. And this will return an order ID. And remember, this order service will internally call our payment gateway to handle the payment. So internally, once we are calling this endpoint, it will internally call our payment endpoint. And in the payment endpoint means in our payment gateway, we have to pass all the payment related information, as well as we will get the order ID, and based on this combination, a payment will get placed in our payment gateway. And if it is a successful payment, it will return the payment ID and the status in the response. And if the response is true, means the payment has been done successfully, then the order will get placed successfully. Otherwise, there will be a order ID that will get generated, but the status of that order will be failed. I hope this is clear. So since here we have tried to cover all the major endpoints that we need to open up for the user, let's now see what are the other endpoints that we have to open up to fulfill our other requirement. So here if you look carefully, the other requirement is once the order has been placed successfully, the restaurant have to accept the order and a delivery partner should get allocated for the pickup. But remember, this is not a public API. These are all the internal API that our function will call internally. So we do not have to list down all those things over here. Rather, what we will do, we will expose one more public API to give the status of the delivery partner once the order has been placed. So there will be the last and the final endpoint, and that is to get the tracking information of a delivery partner. So the last endpoint will be a get endpoint to track a particular order, and this is how it will look like. So this is how our tracking endpoint will look like, where we are sending the order ID as a parameter, and based on this order ID, we will be sending all the metadata that we need for tracking. Means whether the food has been prepared or it is dispatched, and all those information we will be returning from this endpoint. So I hope you guys are clear with what are the core major API endpoints that we have to expose for our front end to fulfill all our function requirement. And as we are done with the third step of our designing, and that is the API designing, let's move to the next phase of our designing, or the next step of our designing, and that is the high level designing of this system. And as I tell you, high level designing of this system will be pretty easy if you have managed to design until this point. So let's move to the next step of our designing, and that is the high level designing of this system. So let's start with the high-level designing. So the high-level designing of this application is actually quite simple. So just remember, like any other system designing, we have to first draw our users. So here what we will do, we will first draw the user who is actually using our application. So here we will be having the user. But remember one thing, this designing is a bit different from all the 5 to 6 videos that we have done previously, because in our previous videos, we have only taken into consideration the user flow of the system. But here, since we have 3 aspects or the 3 actors in our system, means the user, the delivery partner and the restaurant. So here we have to define all of them. But as of now, let's focus on the first one, and that is the user flow of this application. And obviously, since here we are going with the microservice application, and that is why we need to have a load balancer and the API gateway to interact with our backend. So here this will be our API gateway and the load balancer, and the main functionality of the load balancer will be evenly distribute all the traffics across all our backend services. And as you know, responsibility of the API gateway will be routing of the traffic, rate limiting, and user authentication and authorization. So in this high level designing, we will simply mention all of this over here. So this will be the roles and responsibility of the API gateway and the load balancer, that is authentication and authorization, rate limiting, routing, and the load balancing using the round robin algorithm. So that's it for our API gateway. Now let's see what will be the service that we need to design over here. So if you see the first requirement, that is the user registration. So obviously we need a user service to onboard all our users in our application. And for that, what we will do, we will be having a user service over here, and obviously we need a backend database to store all the user related metadata in this database. So here we will be first defining our user service, and this will be our user DB. I hope this is clear, and if you are following my previous videos also, this is the same flow that we are doing. So what is happening? All the requests are coming to our load balancer and the API gateway, and based on the URL signature, that is what we have defined over here, our API gateway will route the traffic to the user service. And once the request goes to the service, based on the request, it will hit the user DB. So this is the simple flow. Now let's see what will be the other service. So here if you see, the other service that we need is we have to list down all the nearby services based on the user location. And also we have to give a provision for the user to search restaurant based on the title and the menu. So obviously there will be a search service that is needed in our system to actually query our database. So for that, what we will be doing, we will implement a search service in our application. And obviously our search service need a database from where it can retrieve the data. And obviously when we are searching something in our application, we want the metadata of the restaurant. So here obviously our search service will query our restaurant database. So here we will be having a restaurant DB, and this will be our search service. I hope it is quite simple and straightforward. So user is trying to search for a restaurant. So the request will come to our search service, and from there, based on the query parameter that the user is sending to us, means the latitude, longitude, title and all these things, we have to query our restaurant database to find out the relevant content and show it to the user. And the responsibility is totally on the search service to give the relevant information. So that is done. Now the next thing is like, obviously once all the metadata of the restaurant comes to the front end of the user have to select the list of food item he want to order. And for that, what user will do, he have to add it to the cart. So here we will be having our next service called the cart service. And obviously when the user is adding an item into the cart, we have to persist that data in our database. Otherwise, once he come back to our application, all this data will be gone. So here we will be having a cart DB to save all the list of food items that he is putting in the cart for future ordering. So here we will be having our cart DB and the request will come from our cart service. Now the next thing is like, once the item is in the cart, you have to place the order. And for that, we will be having a separate service called the order service, whose main responsibility is to confirm the booking in our application. So here we will be having our order service. And as I was discussing previously, that is, an order is a two-step process, because once you are placing the order service have to internally call the payment gateway to confirm the payment. So here, instead of directly inserting that value into our database, first thing that we have to do, we have to call a third-party service, and that is the payment gateway. So here we will be having a payment gateway to handle all our payment related information. And once the request comes from the payment, means the acknowledgement comes from the payment gateway that the payment has been done successfully, then only we will insert that data in our order DB. Means a particular order has been successfully placed in our application. But even if there is a failed transaction, that we will also insert in our order database, but we will mark that order as failed transaction. So here we will be having our next database called as order DB. So I hope we have already covered everything that is needed from the user aspect. So here you can see we have a user service to onboard our customer. We have the search service to search all the relevant food item and the restaurant. Here we are having a cart service where the user can place the item in the cart. We are having an order service where the user can actually place an order, and we are having a payment gateway to accept a particular payment. So here we are done with the user aspect of the story. Now let's go to the next functional aspect, that is the restaurant part of the story. So what we will do here also, we will draw few of the clients to represent restaurants in our application. And same thing will happen also over here, means we will be having a load balancer to handle all the requests of the restaurant. So here you do not need to go in detail of all these things, because you have already explained the role of the API gateway over here. So here we will just define that we are having the restaurant clients and the API gateway to handle all our requests. And here we need to define two major services. Number one is the restaurant service, means obviously whatever the details that are present in our restaurant database, that should be uploaded obviously by individual restaurant. So obviously if I am running my own restaurant, so all the metadata of the restaurant, means what are the food items that are available, what is the location, and all those things, it is my responsibility to upload in the Zomato or the Swiggy database. So obviously here we will be having our next service called the restaurant service, and the role of this service will be to take the input from our restaurant and then update this restaurant database. So here all our restaurant will hit our API gateway over here, and based on the routing, it will land to our restaurant service. And this restaurant service will update all the metadata of our restaurant database. Now the next important service that we have to develop over here for the restaurants, that is our order related service. So here we will be having another service called as an order service. And the main role of this service will be, once an order has been placed into our order DB by our users, it will send a notification to our order service, and from this order service, an acknowledgement request will go to all the restaurant to confirm the booking. So if you remember, when you place an order in Zomato or Swiggy, what happens is like, the order gets placed into our application, and after few minutes, maybe a 1 or 2 minutes, we get a notification in the pop-up or somehow that the restaurant have accepted your order. Means what is happening is like, in behind the scene, Once the order has been inserted into our database or the order has been placed, a notification call goes to the restaurant that someone have ordered a particular food on your restaurant, and on receiving that order, restaurant have to accept that booking or accept that order to confirm the user that the order has been booked successfully and it will get delivered soon. So here we are trying to mimic that flow only. So obviously, since this is a high level designing, you can see I'm just implementing the user flow, that how the things will happen over here. We are not going into the detail that how this thing will interact, how the acknowledgement will go. All those things we will discuss in our next segment, and that is the deep dive analysis or in the low level designing. Now let's go to the next thing, that is, once the order has been placed successfully and it has been accepted by the restaurant, the next thing what we have to do, we have to allocate a delivery partner for that order. So here we will be having another important service called as the delivery matching service. So here we will be having our delivery matching service. And this delivery matching service have a crucial role, that is, once the order has been placed successfully and the order has been accepted by the user, it have to look for all the delivery agents that are present nearby to the restaurant. So obviously, these delivery matching services need a database, and that is the delivery partner database, where we have all the information about the delivery partner. So here we will be having another database called as the driver DB. And this driver DB will have all the information about what is the present location of the driver, what is the status of the driver, means whether he is sitting idly or he is delivering our order. So all this metadata of the driver will be there in our driver database. So here what will happen? Once the order has been placed successfully and accepted by the restaurant, it will fetch all the unassigned order from the order DB and it will assign a delivery partner to that order ID. Clear? So this is how the delivery matching services is working over here. So it's taking the information from the order DB and it is checking the driver DB to check all the drivers present on that location, and based on that matching and some proximity algorithm that we will be discussing shortly, it is assigning a delivery partner to a particular order. Now comes the main thing, that is how the delivery partner address will come over here. So obviously it will come to the third phase of our development, means here we are having the third aspect, that is we are having the delivery agent over here. So we are having multiple delivery agents in our application, and these delivery partners obviously have to interact with the delivery DB. So here also there will be a load balancer and the API gateway to handle this traffic, and there will be another service called as a location update service. And the responsibility of this location update service will be, once the delivery agent gives a feed into our application with its present geographical location, this delivery service will simply update the information in our delivery database. So for example, this driver is updating its location on each and every 5 seconds. So the updated location of the driver request will come to this service, and this service will internally persist that data into the delivery DB, so that the delivery matching service can check what is the present status of the delivery, and based on that it can allocate a delivery partner to a particular order. So this will be the flow of our system. And once a delivery partner has been allocated by our delivery matching service, obviously the driver will go to the restaurant for pickup. And once the delivery partner picks up the order from the restaurant, what will happen? We have to give a real-time update to the user that your order has been picked up by the delivery agent, and this is the current location of the delivery partner. So obviously here also, this delivery partner will send the real-time update to the user who have actually placed the order. So here if you see, we have tried to cover almost all the aspect of the requirement that we have gathered. So here we have completed the user flow, means how the user will be placing the order. Here we are having restaurant flow, means how the restaurant will update the restaurant database, and once the order has been placed, how the notification will go to the restaurant for acknowledgement and processing of the food. And once the restaurant have accepted the order, our delivery matching services will check the driver database to check all the drivers who are present nearby to the restaurant, and based on that it will simply assign the driver to a particular order. And once the order has been picked up, up by the driver from the restaurant, a real-time notification will go to the user about the current location of the driver. So as on a high level, I hope this is clear that how we are solving the problem and how we are trying to solve all the functional requirements that we have gathered. But if you look carefully in this high level system designing, there are lots of concepts that are missing. So here you can see there is no way it is connected that how the delivery partner will get to know that when the restaurant is done with the cooking and ready to dispatch. All those things are missing on this designing. And obviously there is no notification system that is defined over here to let the user know all the status of the food delivery. So here though we have tried to cover all the functional requirement of this system, but there are a lot of things that we have to go in depth and we have to explain in detail during your interview that how the things will work. And for that, what we will do, we will go to the next stage of our designing, that is the low level or the deep dive designing of this system, where we will see in detail that how the user service will work, how we will save the data in our user service, how we will search in this massive restaurant database, what type of database we will be saving, how we will find out that what are the nearby restaurants that are available for a user. All this concept we will be discussing in our next step, and that is the low level system designing. So let's move forward to the next step of our system designing, and that is the low level or the deep dive system designing. So let's start with the deep dive designing of this system, where we will do in detail designing of each and every component that we have discussed so far. So what I will do, I will simply copy our high level designing in our low level designing section. And let's now start with the first component, and that is the user service. So as you know, the user service is solely responsible to onboard new customer into our application. And along with that, there is one more responsibility for the user service, and that is the login. So once the user log into our application, it will first validate the user credential from this user database. And if it is a valid match, then what it will happen, it will give in response a JWT token by which user can make all this subsequent call. So here what we will do, here we will be having our user service, and this will be our user DB. And as you know, the user DB is a very much a relational database. So here we will consider a simple MySQL database. But let's see what will be the schema structure of this user DB. So this structure will be more or less the same thing that we have done in our previous video. So let's see what will be the schema structure for this user database. So this will be our user database, which can be a MySQL or a Postgres database. And here the attribute that we will be saving is the user ID, email, password, address, and all other metadata that are required to onboard a particular user. So this will be our first database, and that is the user database. I hope this is quite simple and straightforward. Now let's move to the next service, and that is the search service. So here we have the search service, and the responsibility of the search service is two things. One, once the user lands to our application, we have to list down all the nearby restaurant for the user. And number two, once the user tries to search for a restaurant or the food item, we have to find out all those relevant information for the user. So that are the two main responsibility of the user service. And as you know, as we have discussed in our previous all of 6 videos, whenever we are implementing a search service based on the title and the location, we will simply go with the Elasticsearch. And why we are using the Elasticsearch, I hope this is clear, because I have already explained you in detail in my earlier video why there to search for a particular hotel based on the location as well as with the name, we were going with the Elasticsearch. So similarly over here, since the requirement is more or less same, that is we have to identify the list of restaurant based on the title and the location. So here also we will be going with the Elasticsearch approach. So here what we will do, here we will introduce one more component, and that is called as Elasticsearch. So here I have introduced a Elasticsearch. Please make a note that if you do not understand why we are using a Elasticsearch, go with my previous 2 videos. There I have explained you in detail why we are using a Elasticsearch, because during your interview, if you cannot justify that why here you are using a Elasticsearch rather than a Query or a Postgres solution with a GIX extension, all those other alternative approaches, then it might be a negative impact for your interview. So go through my earlier video, So there I have explained you in detail. So here, based on the assumption that you know why we are using a Elasticsearch over here, let's proceed further. So we have the Elasticsearch, and obviously Elasticsearch have to query a database. And here the database that Elasticsearch will be querying, and that is the restaurant database. So here internally the Elasticsearch will query our restaurant database, and there will be no connection between the search service and the restaurant service, because here the search service will never query our restaurant database directly. And another most important thing is like whenever the restaurant manager or restaurant owner is uploading the metadata of the restaurant, there we have two components. One is the title, description, metadata, all the textual form of the information for a restaurant, and another is the images of the restaurant, because obviously the restaurant will be having the images and also the food items that a particular restaurant is delivering. Each and every food item will have an image associated with it, and to store all those information we will be using a blob storage or a S3 bucket. So here what I will do, I will divide this component into two parts, and for that I need some space, so I will just move this component a bit. And here what I will be doing, here we will be having our restaurant database. And apart from this database, there will be another thing, and that is a blob storage or a S3 bucket. And this S3 bucket will store all the restaurant images and also the images of the food item. I hope this is clear, and this search service will directly talk with this S3 bucket. So what is happening is like all the metadata and the textual information are stored in our restaurant database, and all the images and the videos of the restaurant or the food item will be stored in this S3 bucket. Now let's see what will be the schema structure of this database. So here if you look carefully, restaurant database is also a relational database, because here there is a lot of connection between the restaurant and the food items that are available. And that is why, since here we have to maintain a relationship between the restaurant and the available food item, here also we will go with a simple Postgres solution. So the first table within this database will be the restaurant DB. So let's see what will be the schema structure over here. So this is how our restaurant database will look like. So here we have a restaurant ID, the name of the restaurant, the textual form of the address, the status means whether the restaurant is open, closed or under maintenance. Number 2, the geolocation means the actual latitude and the longitude of the restaurant. Then the array of the images of a particular restaurant. And what here we will store is the URL location of the S3 bucket. So for example, there is an image of the restaurant in this S3 bucket. Here in this array, we will save the URL of that images which is stored in the S3 bucket. I hope that is clear. And there will be some other metadata that will be associated. So this will be the first schema for our restaurant DB. Now there will be another table within this restaurant database, and that is the foods that are available within the restaurant. So that is nothing but a menu card for each and every restaurant. So let's see how the schema will look like. So this is how the schema of the menu will look like. So we will be having a menu ID. Then we will be having an item ID for each and every item. Now there will be a restaurant ID which is linked with the item ID. Now there will be title, description, the image URL, category, price and all the other metadata. And here also the real image will be stored in the S3 bucket. So here mostly these are the two table structure or the two schema that we required for our restaurant database. So here we are having the restaurant database and the menu item link with each and every restaurant. Now the question is, as you know, how the information within the restaurant DB will go to the Elasticsearch. And for that what we do, we use a CDC pipeline. So the pipeline that we have defined over here will be a CDC pipeline. And the consumer service that will be there within this CDC pipeline will be responsible for merging these two tables together and put it in a document format within this Elasticsearch, so that it will be easy for the user to search any relevant information based on any attribute that is present within the document. I hope this is clear. This is more or less the same way or the same approach that we have done previously. So here we are done with our second service, and that is the search service. Now let's go to the next service, and that is the cart service. And here also the cart service is a very straightforward, simple solution, and that is adding item in the cart. And for that also we will be using a simple Postgres database. Just I will show you how the schema will look like. So the schema will look something like this. So the schema structure of the cart DB will look something like this. So we are here, we are having a cart ID, the restaurant ID for which the cart has been formed, next the user ID, next the list of items that are in the cart, and after that some of the other metadata if required. So here if you look carefully, once you add an item in the Zomato application, your cart changes with restaurant. So for example, you cannot mix match the item from one restaurant to the other. So once you switch from one restaurant to another restaurant, your cart gets empty and it is a new cart that gets created over each and every restaurant. And that is why here I have given the restaurant ID for the cart DB. So for each and every restaurant, there will be a separate cart that will get created. And this will ensure that you cannot add food items from different restaurants and order together. I hope this requirement is clear to you. Now let's move to the main service, and that is the order service where all the story starts. So here what we will do, we will expand this thing a bit because there are a lot of things I have to show you in this order service. So as you know, the main responsibility of this order service is to place the order, means the entire checkout process. So the first thing that will happen is like once the order has been placed, it will go to the payment gateway, and once the payment has been done successfully, after that only all the other steps related with the order will take place. So here what we'll do, we will break it into two steps. So the first step is like once the user is trying to place an order, it will first land to our payment service. So here we will be having another service, and that is called the payment service. And the responsibility of the payment service will be to capture all the metadata of the payment, means all the card details, the CVV, expiration date and everything. And once all those things are taken care, then it will call a third-party application, and that is a payment gateway. So here internally this payment service will call the payment gateway where the actual transaction will take place with the bank. And once the transaction takes place with the bank, obviously we will get an acknowledgement from this payment gateway whether the transaction was a failed transaction or it was a successful. And that information we have to store in our database. And for that we need another database, and that is called a payment database. So here I will introduce one more database, and that is called the payment DB. And as you know, the payment related information need to be highly consistent, and that is why blindly go with a MySQL database. So let's see how the schema will look like. So this is how our payment DB will look like. So here we will be having a payment ID, a user ID, a order ID, the amount, the currency, timestamp, and all other metadata related to payment. So this will be a simple structure. So this will be our payment DB. So I will keep it over here. Now, once the payment has been done successfully, two things will happen. Number one, we have to notify the user that the payment and the order has been placed successfully. And number two, we have to notify the restaurant also that an order has been placed for your restaurant. And as I've told you in my earlier video, whenever a particular service is going with a multiple phase commit, then you have to go with the event driven solution. So here if you look carefully, this order service have to do multiple things. Means here the order service have to update the user or notify the user. Next, it have to update the order database. Next, it have to notify the restaurant that an order has been placed. So since here multiple action item is there on this order service, so what we will do, here we will be going with the event driven service. So here the order service, instead of doing all these three action item concurrently, here we will be using a Kafka broker to do so. So what we will do, here the order service, instead of updating this order DB, here the event that an order has been placed, we have to put it within a Kafka broker. So let me first draw this thing. After that, I will show you what it actually means. So here we are having a Kafka broker, means whenever an order has been placed successfully by the user, that event will get posted within this Kafka broker. And here within this Kafka broker, there will be multiple topics which will be responsible for doing a particular action. So here the first topic that will be placed is the order topic. Means once the order has been placed, an event will get generated and it will be placed within this particular topic. And once an event comes within this topic, multiple things will happen. First, there will be a consumer service. We can call it as an order place service or an order consumer service. And the role of this order consumer will be to update the order database. So once the order has been placed, this order consumer service will pick that event from the Kafka broker and it will simply update this order database. Means for a particular user, there is an order that is placed in our application. Number two, we have to notify the user that the order has been placed successfully. So from here, there will be another service called a notification service whose responsibility will be to update the user that the order has been placed successfully. So here we will be having our next service called the notification service. So this will be the second action item. So two things are done. One is updating the order database and number two, notifying the user. Now the next step is like we have to notify the restaurant that there is an order that is placed in your restaurant. And for that there will be another third service called a restaurant acceptance service. And here in this service, what we will do, we will simply raise a notification to the restaurant and we will ask the restaurant to accept or decline the order. So here we will be having our next service and this will be our third service and that is the restaurant acceptance service. And here what will happen, a HTTP or a long polling request will go to the restaurant for accepting the order. So here instead of going the notification from this order DB, what will happen? So this restaurant acceptance service will trigger a notification to this order service and this order service will internally notify the restaurant that a particular order has been placed in your restaurant. And once the restaurant accept the order, an acknowledgement will come from the restaurant to this order service that the order has been accepted by the restaurant. And once the acknowledgement is received from the restaurant, this order service will put that event in the Kafka broker. So here we can simply use this Kafka broker also. But since I do not have that much space, I will define another Kafka broker over here. But it is the same Kafka broker that we are using here also. So we will be having the Kafka broker over here to capture that the restaurant have accepted the order. Now once the restaurant have accepted the order, again we have to do a couple of things. Number one, we have to notify the user that the order has been accepted. So it will call the notification service. And after that, what we have to do, we also have to assign a delivery partner for that order. So here two things will happen. So here we will be having number one is the order status, means the order has been accepted by the user, and number two, we have to assign a delivery partner. So there will be another topic over here. So I hope this is clear. Once the order has been placed successfully over here, we are sending a notification to the user that the order has been placed. We are sending a notification to the restaurant that there is an order that has been placed to your restaurant, and this order service internally notify the restaurant that there is an order. And once the order has been accepted by the restaurant, the event will come into this Kafka broker. And once the event comes to this Kafka broker, two things will happen. Number one, we have to update this order status that the order is confirmed. And number two, we have to assign the delivery partner for the order. And here to update this order status, what will happen? This consumer service will talk to this Kafka. So basically these are the same Kafka that we are dealing with. So here once the order status changed to confirmed, we have to update that into this order database by this order consumer. And how this order database will look like? Here also it will be a simple Postgres solution. So let's define the schema structure for this order database. So this will be a simple straightforward implementation. So here we are having an order ID, user ID, restaurant ID, the list of items that has been placed, the price, currency, time, and other metadata that we require. So here we are done with the order DB. Now comes another main thing, and that is assigning the delivery partner for a particular order. So here what will happen is like once the order has been accepted and an event has been placed within this topic, a request will go to the delivery matching service. So what will happen is like this delivery matching service is nothing but a consumer service which is talking to the Kafka broker using the Kafka connect. So here this is the path, and the responsibility of this consumer service to assign delivery partner for all the accepted order that are placed over here. So here this consumer or the delivery matching service is actually connected with this Kafka using a Kafka connect, and it is constantly reading all those orders where the delivery partner has not been assigned. And let's assume right now that somehow this delivery matching service have managed to found out a delivery partner for your order. And once a matching driver has been found out at your location, what it will do, it will again post an event in the Kafka broker. Means here it will again talk to the Kafka broker that a matching driver has been found for a particular order. And once this acceptance or the acknowledgement get placed in this topic, means a particular order or the particular life cycle of the order gets completed. Means the order has been placed, it has been accepted by the restaurant, and a delivery agent got assigned to the order. And once finally this event gets generated in this Kafka broker, means a delivery partner got assigned to your order. And thus what will happen is like, again this order consumer service will read that event from the Kafka broker, and it will update in the order database that for your order we have assigned a delivery partner. So what we will be doing here, we need another attribute, and that is the driver ID. So once the delivery partner has been found for the order, it will simply update the driver ID for this order. I hope this cycle is clear. Now let's see how this delivery matching service will find out the matching driver in the location. And the best way by which the delivery matching service will find out a particular driver in the location is by using a geohashing service. And what is a geohashing service? I have already explained you very briefly in my previous video. But don't worry, in my next video, I will completely create a separate video on the proximity search, where we will discuss in detail that what is a search by query, what is a search by Elasticsearch, what is a search by geohashing, and all those things we will discuss it in detail in our next video. So do check out my next video and please subscribe to my channel. So here now we will just assume that there is a proximity search algorithm that is defined within this delivery matching service, and the algorithm that we will be using is the geohash service. So I will write it completely over here. So here we are using a geohash for doing a proximity search, and we have to find out all the nearest driver who are sitting idly, because obviously once a driver is already allocated with the order, we cannot reassign the same driver for another order until and unless he is done with his previous order. So here we have to look for the ideal driver that we have in our database, and how we can track the ideal driver, that we will discuss it over here. So let's see what is happening over here. So here we are having all the drivers present across different locations, and here what will happen, on each and every 5 to 10 seconds, these drivers will send a notification about the current location and the status of the driver into our location update service, and thus the location of the driver will get updated in our driver DB. But this is not at all simple the way it is looking, because if you know, there will be thousands and thousands of drivers across the globe, and if each and every driver is sending the status of the driver on each and every 10 seconds, there will be a tremendous amount of requests that will get hit within this location update service, and it is not possible for a particular server to handle that amount of load. So instead what we will do, here we will update the structure a bit. So here what we will be having, here we will introduce a Kafka gateway. So here we will be having a Kafka gateway, and here instead of this load balancer and the gateway for the API, we will introduce a Kafka gateway for this driver service. And once here a particular event of the location gets generated from the driver, it will simply get updated to a cluster of Kafka brokers present over here. So here we will be having another Kafka broker to capture all the location update for the driver. So here we will be placing one more Kafka broker to capture all those events. And once those events, means all the location of the driver is there within this Kafka broker, the responsibility of this location update service will come. So this will be nothing but a consumer service over here, which is reading the event from this Kafka broker. And here what it will do, instead of directly updating the driver database, it will update our Redis cluster. So let me draw it over here. After that, it will be easy for you to understand what I am doing. So let's see what is happening over here. As you have understood this fact that there will be thousands and thousands of the event that will be coming from the drivers to update their current location. So what we will do, instead of directly updating the driver database, we will keep it in a local cache. So obviously those amount of requests we cannot write in a consistent and in a real-time way in a particular database. So what we'll do here, instead of writing it directly to the database, we will keep it in a local cache. As you know, the updating or the writing time on a cache is very less than updating a database. So here, to make our services a near real time, we are updating the Redis cache over here, and this driver matching service will also read it from this Redis cache instead of going directly to the driver database. So this will make our system very much reliable, consistent, and near real time. So I hope this is clear, and here we are also putting a TTL for each and every driver. So it might can happen that a driver is sitting idly and it is constantly updating its location through this process, and at some point his network got lost. So for those type of drivers, we have to place a TTL over there. For example, if the driver is updating this location every 10 seconds, so here also our TTL will be every 10 seconds. Means if we are not receiving the response on every 10 seconds, we will assume that the driver is lost or we cannot talk with that driver. So obviously for that driver, we cannot assign a particular order. And to handle that thing only, we are placing a TTL over here. I hope this is clear that how the driver is constantly updating our database and how we are assigning a delivery partner for each and every driver over here. Here, if you look carefully, we have almost covered everything that is required in our designing. Starting from the user aspect, then how the restaurant will accept the order, and after that, how the delivery partner will get allocated for a particular order. Only a small thing that is missing, that is how the user will get the real-time updates from the delivery partner once the order has been picked up. So that is the only thing that is pending. But apart from that, there is one more small concept that is missing. So here, if you look carefully in our designing, what we are assuming that our delivery matching service will try to find out a delivery partner who is sitting idling near to the restaurant. But actually what happened in the real world is, apart from just sending the notification to a particular delivery partner, what the delivery matching service does is like it sends the notification to multiple drivers on that location, and whoever accepts the request, that delivery partner gets allocated. So that small part is missing, and the way to implement that is more or less the same thing the way we have done for the restaurant. So here also, if you remember, our order service was there responsible to get the order confirmation from the restaurant. So here also for the delivery partner, there will be one more service for the confirmation. So what will happen once the driver matching service find out a list of delivery partners near to the location, it will send the notification to all those drivers. So there will be another service called as delivery acceptance service. And the role of this service is to get the confirmation from the delivery partner that do you want to accept this delivery or not. Means whether he want to deliver the food or not. So here what will happen, this notification will go to all the driver that are sitting idly on a particular location, and obviously this request cannot go directly to all the delivery partner. So here there will be another API gateway through which all this request will go, and through this API gateway the request will go to each and every driver on that particular location. And once the driver accepts the order, from here the request will go to the Kafka with the confirmation as yes. So here I will just clear it out a bit. So this is how it will look like. So actually what will happen, once the delivery matching service gets the list of all the drivers near to the restaurant, it will send the notification to all the drivers. So here the request will come from this delivery matching service to this delivery acceptance service. And from here the request will go to the API server and it will trigger a notification to each and every driver that are available. And once the driver accepts the order, the confirmation will come to the delivery acceptance service, and then it will land to the Kafka, and from there everything will happen the way we explained. Means our order consumer service will consume that event and it will update the order database that we have over here. Means the driver has been allocated for this order. So this was an extra step or a hop that was missing in this design. Now the next and the last final bit that is missing is to update all the user with the real-time location of the driver once the order has been picked up. And to implement that, what we will do, we will be using a WebSocket connection. So from here, we have to open up a WebSocket connection to give the real-time location update of the driver. So here we have to open up a WebSocket connection, and for that, we will need a WebSocket manager. And the role of this WebSocket manager is to handle all the connection efficiently, because as you know, opening a WebSocket is a very process intensive job and it takes up a lot of memories of the server. So we have to efficiently close and open all the connection, and for that only we need this WebSocket connection over here. So all the driver will open up a WebSocket connection once the order has been picked up, and it will get updated to all the user through a WebSocket gateway. So here we will be having a WebSocket gateway through which the driver will give the real-time update to the user. And thus here we complete everything that we need for this design. But there is still a small piece of information that is missing. That is, how would the driver will know that whether the order has been prepared by the restaurant for delivery or not. And to implement that, what we need, here we need one more service called as a order confirmation service. And this service will talk to the Kafka broker that we have over here. Means once the food has been prepared, the restaurant will send a notification to this order service and it will update the status of the order that this order has been cooked and ready to dispatch. And once that event comes to this Kafka broker, here our order confirmation service will send the notification to that respective driver that the food has been prepared and you can come for the pickup. And thus here you can see we have covered everything that is required for this food delivery application. I hope you have clearly understood that how incrementally we have developed each and every features over here. But believe me, you won't be asked so many questions and you won't be asked to elaborate each and every component over here. Since in this video, I was trying to cover all the aspect of the food delivery application, that is why it became so huge. But during your interview, you will be either asked to develop the user aspect, or you will be asked to develop the restaurant aspect, or you will be asked to develop the driver aspect, not all the three. So it is better to know everything because you do not know what question your interviewer will ask during your interview. So I hope I have tried to cover everything that is required to design this food delivery application. And if you have liked this video and if you have found this video useful, do not forget to like, share and subscribe to my channel and hit the bell icon so that you never miss any update from my side and you are always ready for your next interview. So in our next video, we will see in detail that how the proximity search works, means how we should design a quad tree or how we should use a geohashing technique to find out all the nearby places near to a particular geographical location. So see you on our next video. Thank you.